Okay, everybody, let's start. A warm welcome to this first webinar provided by EKTOS Development. I'm not going to say much other than I wish to hand over the floor to our development director, Alexander. So, Alexander, take it away.
Thank you very much, Nils Martin. Hello, everyone. Welcome to this webinar. So today we're gonna talk about lifecycle and development process in IoT projects, and this webinar is one of 3 webinars we're gonna make during this fall. So let's move on. Let's see what we've got. So about today's agenda. Well, we'll talk about a little about EKTOS and Speaker. We'll look into what we actually call an IoT product and just try to narrow down a little bit this term. We'll look into the typical life cycles of the product development, see, I would say, the classical process of hardware and software development, understand what alternatives could be, look into the challenges in IoT products development processes, and then kind of wrap it up and see how we can partner together to make your products. So a little about EKTOS. Who are we? Well, basically EKTOS is Danish-born consultancy, started in 2007 in a small town called Vivo. You probably know where it is. Now we are represented by roughly 110 guys across 3 business areas. We run an EKTOS, and the one that is presenting today is electronics development. This is where I'm in charge of doing stuff. Then we have type testing and approvals business area, and electronic manufacturing services, where we manufacture electronics for our clients. The locations where we presented are actually in Denmark and Ukraine. In Denmark, we have 3 offices in Copenhagen, and in Ukraine, we are in city of Ivano-Frankivsk, that is very close to the Polish border. I think development is so far the biggest business area. We having 51 guys on board. And in regards to IoT, we have been doing roughly 50 some IoT projects with the budget or turnover of roughly 35 million Danish kroner. A little bit about myself. My name is Alexander Lubimov. I'm project director in EKTOS Development. I'm working as part of EKTOS team for 15 years. I think it's gonna be soon 15 years. My main target and actually interest is to help clients to mature the product ideas and actually kick off the products and get those projects to the mass pro in a really smooth and good way. Just to let you understand who my background is, actually master in computer science and electronics lately, and now I'm also working on my PhD studies, trying to kind of spread the IoT knowledge to the CubeSats, to the nano satellites that are put to the Earth's orbit. Okay, let's talk about IoT products. What we will call as IoT product in this presentation. I would say, in general, IoT is super wide topic, and it's really wide what we can call IoT. Like 10 years ago, IoT was something really complex and having super powerful MCUs and stuff. Today, with the hardware integration or integrity into more powerful cores and the small electronics, IoT is always a little kind of less complex than we tend to think. So in this presentation, we'll say that the IoT product is medium complexity hardware solution. So it's not something big, but also not something extremely tiny, like just a radio and few components around. It is often battery or mixed battery and grid powered. I would say a lot of smaller IoT products are just battery powered. Then apparently product connects to some sort of network infrastructure, cloud to server, via some kind of wireless. Again, it's like, battery powered or grid powered, same goes here. We have mainly wireless connectivity, but also sometimes wired connectivity if it's required by the application. All right. And then the IoT product basically often has the limited complexity of the data processing. What I mean by that is that it's not something, we will be not concerned today about edge computing. We will be talking more about, sensor-like IoT products. And what I want to say is that the main product value in this case, in those IoT products, is delivered at the front end, and this is where end user can get access to, where end user can also look into the application running on his smartphone, and that's how the value is delivered by the IoT product to the end user. All right. If you look into the infrastructure, then we can see that there are several layers of what is IoT product normally. We in EKTOS concentrate mainly on hardware and firmware development. So this is why we'll be mainly concentrating today about, the pitfalls and, kind of, I would say, peculiarities in the process of developing these parts. But also, if you look a little bit up here, then I can say that, we have the brokerage layer. And in this brokerage layer, we also have a different way of, sending the data. Then data from the brokerage layer is pushed to the cloud and server, where we can run, the product-oriented business logic. And then we have the last part of it is we having actually the front end and smart app thing. Or we can have another IoT product being receiving the data that is harvested by the product we are discussing or we're constructing. So today, our main interest will be in looking into the IoT product development at firmware, hardware, and a little about connectivity to the brokerage layer. Okay, let's look into typical product development lifecycle. As many of you have been through the cycle, I believe many times, that product development idea starts with discovery, then you define the product, then you design, meaning you kind of play with different technologies to see what is feasible for your product. You do planning of the development, selecting development partners and stuff, and then you move to the biggest part of it, that is called development. And this is multi-iteration process because modern, even small IoT devices, they have reasonably high complexity, especially when we're talking about software and its cyclomatic complexity. So what happens is that you really have to run this process iterationally. So this is understood. And then what happens next is that we go to the launch and commercialization of the project. And here we have a lot of unusual stuff for if you compare IoT product and classical electronics. And majority of this unusual stuff comes to, to some challenges with, with the data size we are talking about, because IoT means really mass deployed. So when we deploy the product, actually the data streams, the amount of data you have to work with is really big. So this is one of the, I think, peculiarities, what you have to remember when you deploy the IoT product. Then, of course, what happens next is that you get to know your product better. And then of course, you kind of cycle in the product life cycle between developing here at the blue box and then launching the product and getting back to the development again. And why is that? Well, first of all, the redeployment and redevelopment is quite hardly driven by, as I call it, smell of data. Because when you get to know the data you're harvesting with your IoT products, you see new business values, new revenue streams, new ideas how you can better serve your end clients or users. What happens also in the IoT products is that the lifetime of the product is actually shorter, because the data that is leading to the change of the product kind of, igniting the change. You also have the technology push and technical singularity, meaning that what was developed 10 years ago based on, let's say, 2G connectivity is not really that fruity today. So you have to really follow the technological push from the products. And this is also what really kicks in and push your product from the already launched and commercialized product back to the development. So you have to redevelop, you have to really respond to the technological challenges. And then what happens also is that, when having mass scale developments and deployments, you actually kind of tend to follow simply mass scale, mass and like social impact changes. So if let's say, what shall I bring as an example? Let's say the way of making the payment in the public transportation is changing because people suddenly want to use their smartphones more. Then apparently you have to redevelop the product that kind of fulfill the social changes. That's what happens. What are the risks because of all this? Well, first of all, having mass deployments, you have really a lot of data over time. And what can go wrong with the data is that you lose the integrity. Mainly, this is the problem mainly because some of the IoT deployments, they tightly connected to the machine learning and big data algorithms. So the integrity is definitely a big king in this data processing. All right, the next problem is downtime. If it's mass deployed product, downtime is really a problem because you have really challenges when demand and expectation from the IoT products is that they are simply 24/7 available. And especially having products deployed across geography, you have to really fight with downtime problems, because even if you kind of deploy new firmware or something else, you have to respect the time zones and stuff. So it gets kind of complex. The next challenge and the risk is backward compatibility. Whatever you're changing, you have to really respect the legacy of your product. And quite often, due to the different business values or revenue streams being started, this backward compatibility can be not as transparent as we might want. So in this backward compatibility process, we have to really use some expandable data models so we can ensure that the product lifecycle is kind of backed up by that. All right. And well, the last but not least, and actually pretty big risk is that whenever we think that the product is finally there, we kind of get to the value we want to bring to the clients. This all-inclusive way of making the product suddenly gets to the point where, it's just yet another MVP. And why is that? Well, simply because products are having their own life cycles and they are changing on the way. And that's what normally happens quite often. Okay, let's talk a little bit about what is the classical electronics development process. I know that it's a lot of small circles, but basically the process is somewhat waterfall-like, because we know that we start with specification at the very left, we move to design and architecture, we do some prototyping here and there, maturing the hardware of the project, and then we do EMC testing, approvals, get to the final prototype, do final MC, and then we kind of mature the product in the manufacturing and gets to the mass pro. What are the problems in this process? Well, apparently having the nature of waterfall process in general, we are facing some well-known problems. One of the problems is that you have a little, I would say, offset between developing your hardware and software, because hardware is what normally kind of more important at the first stages, because you want to prove that, you know, the mechanics is good. You want to prove that power consumption is great. You need to prove precisions. You need to test your sensors and stuff. So basically what happens in the beginning is that you really spend a lot of efforts on bringing up hardware to the point where it's kind of not that shaky or buggy anymore. So you kind of postpone the firmware, guys. So they develop software a little later in the process. Okay, you know, this also pushes back the problem that in the beginning you concentrate on supporting your hardware team to kind of understand that the hardware can be matured more and actually go to the more mature prototyping phases and EMC testing and approvals, especially if it's worldwide approved. And then what happens is that your concentration is mainly on the system functions, not the business functions you're addressing. So you're kind of looking into, you know, hardware abstraction layers, drivers, optimizations here and there. And that's what really takes a lot of time in the beginning. What then thing you can face? Well, you can apparently face some problems where, you know, the business functions are delivered too late. And what happens here is that you really push the business or the product team to start experimenting with your products too late. So and then you kind of squeeze the improvements for the product features too much. And yeah, it just tends to get to the very end of the development process. Then of course the thing what really also pushes here is that normally, if you look into the classical development process like here, you tend to integrate with the third party when you have the stable product. And the stable product can be really late. It can be, some companies really think that, you know, when you push to the final EMC testing, or even when you get products out of 0 series, this is where you start integrating with someone else, because you don't want to spend someone else's time finding issues, bugs with your product. And that's really what is super tricky in this classical waterfall process. Okay, what then goes wrong if you follow the classical process? What I want to show in this picture is basically the way how the hardware and software develops through the process of the project time. So what you can see here in hardware, you know, kind of pan is that you have several prototypes being built. You have also the green bars here. That's where you do the integration builds of the software and firmware. So this is kind of gates where you try to mature the prototypes and move on with more functions. So what you can see with this line called, you know, actual business features increment is that during the early stages, you actually do not do that much of business functions development. So what happens, you kind of tend to work with the hardware needs. And whenever you think that you are moving on nicely, then, you know, the business functions of the IT products, they just tend to be developed at the very end, I would say at like a last quarter of the project time. And this is really tricky. By this orange line, I show, you know, kind of the ideal quality-driven increment to the business features, meaning that, you know, you kind of sequentially building up on top of the product needs, moving from having 0 functionality to the end of the project where you kind of develop all the business functions. And if we're talking about product development group, then basically this green line, this is what product people expect in the companies, how the product matures. So they kind of give you a little time here in the beginning to start development, but then the expectation grows a lot and then goes to this kind of logarithmic shape in the end where kind of things have to happen as well. So that's what happens. And what is happening also in the very end is that you get to some forgotten, as I say, and production related function implementations, and that also squeezes in some noise, some problems. Okay, so this is how I see quite often what happens in IoT development projects, what is going on. Great. So basically, the main problem, what I wanted to show in this picture, is that the gap between business expectations, well, meaning, you know, the business functions, what exactly product shall do, and what development team considers as their deliverables, is somewhat growing over the project. Apparently, it have to hit the target somewhere in the end, but in reality, this gap is somewhat growing during the project, and it requires some skills and some, I would say, specific methodologies how to squeeze this gap into the smaller one, and that's what we'll be talking about right now. So what are the pitfalls? Why we call that, you know, some pitfalls may wait for you in the very end of the project? And well, let's just admit that unfortunately it's always later stages of the project where we kind of get some non-expectancies, not expected problems to show up and actually kind of, you know, make a great ripple to the development project. So what are these problems normally? Well, I would say one of the biggest chunks of the problems is related to the security implications. Simply, you know, development has been started with some simple expectations. Then when you get to the end, you have security gap assessments. If you use open source software, you have something else. And you know, on the fly, you get to the point where security implications are getting more and more complex. And it is really problematic at the very end, because the footprint of the processors and solutions can be really hard to address these problems in the end. The second problem, I would say, I quite often see what is really challenges and makes a lot of ripple to the development is firmware over the air update. You know, quite often you kind of get to the point where you have to implement business features finally. So you concentrate on that, you push all the efforts into this, and then firmware over the air is just quite often seen as a supplementary function. And what happens is that at the very end of the project, you see that you have the zero batch already of products already enrolled, and that could be in IoT world, it could be thousands of units. And then suddenly you realize that the firmware or the air update has not been tested properly. So you're kind of hitting the, you know, the wall of potential risk of breaking a lot of products. Then I would say two things that are somewhat connected is cost of operation and cost of provisioning, or the provisioning mechanism in general. That's also what really hits the wall quite often, because you tend to select your platform for data integration, is it Microsoft Azure or AWS or whatever else. That gets also kind of late quite often, and then it comes as a really nasty surprise that cost of operation is really high with the data stamping you want to push to the cloud. I think the managerial aspect is we can mention right at the moment is integration with third party. That is obviously always a problem, because quite often it's distributed teams working somewhere else. You need to spend a lot of time on integration and stuff, and that's really gets also a little tricky here. And the hardware related and the product related feature that is only growing in importance and in complexity is the battery lifetime for battery driven IoT products. This is where it's super important to concentrate on this earlier than very end, where you actually get to the measurements and you know, kind of documenting the measurements, because you kind of get the final zero batch for the products. Okay, how do we overcome these problems? Well, I call the process of overcoming these problems is very simple. I call it asynchronous implementation. And DNA behind this asynchronous implementation term is where you kind of completely decouple hardware and software processes of development and concentrate on hitting the targets of these two kind of panes of the, or not panes, but let's call it landscapes of the processes, just driven by some specific integration points as this integrity or integration builds. So this shall be driven more thoroughly, more visible in the teams. Of course, it is important to mention that you need some resource redundancy. So if you are pushed for the resources, you don't have enough developers in the team, that would be a bit more cumbersome, but then you have to really look into sequencing the development and apparently having the impact on the timeline of the project. That would what you need to concentrate on. Okay, so what happens is that you kind of move to the parallel development of system and business functions, as I call them. And this means that you can have a team member, or if it's more complex project, you can have a part of the team concentrating on really fine-tuning the firmware and middleware related to the hardware. And then you can have a part of the team who can work on the business function implementation. And what is really good about that is that you can start working with the non-mature or even hardware based on development kits, somewhat breadboards. And that's really, really important for the IoT products, because you can get faster to understanding what kind of business functions are working, not working, bringing value or not to your product. The good advice here would be to concentrate on agile or safe methodologies, because these methodologies are driving your teams in regards of understanding how you deliver exactly the business functions and business product increment into your products. So let's look a little bit more, I would say, into pitfalls and their explanations. I just want to briefly dive deeper into what I call pitfalls and why they are really important. Cost of operation. What was that I was just mentioning a few minutes ago? Well, it's really, really important to concentrate on, because quite often engineers are making their dream data models, as I say. So they push a lot of data, debug data, and you have the production product, you have the first enrollment, you can see that someone was just pushing some nice data to be there, and it simply eats your footprint at the data model at the cloud. And the footprint size apparently pushing for the cost, and that's really with big enrollments is really, really costly. Okay, the third-party integration. Well, that's, I think, pretty simple. You need to get few teams to work together. You have cloud, you have UI, UX experts working with the applications, with the look and feel, how the end user will consume the data. And all these have to be really kicked off in the beginning. So it's not like you kind of wait with that before or until the hardware is ready. So it's not going to fly that way. Provisioning. Well, what is tricky about provisioning? Well, what is tricky is that in some wireless technologies like NB-IoT, LTE-M, 5G, you have several provisioning steps. The first provisioning step could be, eSIMs provided by the cell data providers, like it could be Telenor or someone else. Then you have provisioning at a cloud service at a data like IoT, Azure IoT Hub or something else. And then you have more provisioning at the end application you are making for the cloud. So if you're not concentrating on the provisioning mechanisms and how to address that could lead also to the major reworks, because it quite often requires, exchanging with security certificates, revoking certificates in the bigger deployments, and it's really down to the architecture of your application. Firmware over-the-air update. Well, I think we already spoke about it. This is really, really complex. and have to be tested properly feature, because it can potentially, within bigger deployments, cost product teams a fortune to actually even recall devices to be properly reflashed and stuff. So this is really important. Security considerations, as I said, important thing. Simply, it's something what really develops every day. If you look into the IoT devices admittance by Amazon AWS a few years ago, that was really simple. You kind of get in touch with the dedicated server, you can exchange data and stuff. Today it's really complex because they want to have security to be in place. It requires bigger footprint of the processor and stuff like that. So it's really developing. We want all the products to be secure, apparently. All right, and the battery lifetime and power budgeting, what I see is that it's really often postponed. It gets in the very end to be a big surprise. Then it tends to really also drive teams crazy to be able to catch up with this, to redesign here and there. It can also potentially, if architectural solution software is not chosen properly, it can potentially also really kick really hard on the redeveloping the firmware. Okay, how do we work with these pitfalls and what are the solutions? Well, as I said, asynchronous process, so we can simply have more time in the very beginning, and this is what I show here as a green box of efforts, and I call it architectural work. So we actually push all these problems to the early architecture and do a lot of proof of concepts here or there, trying technologies out, looking into implementations and doing stuff. Then I think what is really underestimated quite often by development teams is that you need much more hardware to be able to understand the statistics and also the impact on some of the changes. For instance, you want to check your battery lifetime and battery power consumption. And you simply cannot work with one sample. You need to have 5, 10, 15 samples to be able to get some statistical data, plot your distribution on power measurements, and kind of get into the clue what it will mean for the already enrolled product. Okay, concentrate apparently on automated testing to be able to mature a product earlier, because nothing will tell you if the product is as good as it could be in 10 years before you actually pass the 10 years. So the way to kind of trespass this 10 years faster is to do automated testing, simply kind of fastening the product of or the process of product maturity, and also having some proven and used knowledge you can kind of loop back into development project and then base your assumptions and real field experience on. And of course, what I want to really emphasize is that cloud and app projects lately, especially for the small IoT products, they are actually bigger than hardware and software projects together for the IoT device itself. So it means that actually it takes a lot of time to mature cloud and app, and if it's postponed in the process, then you simply risking to reach out to the end of the project without having the solution you would want. All right, as a small wrap up, what I can say, it's a lot of words and some good advices, I know. And as a wrap up, what I want to mention is that the product development lifecycle for the classical products we have been developing 5, 10, even 3 years ago is really different to the IoT products, because we have this loop backs, we have the knowledge, we explore, we kind of tend to use this exploration knowledge to get back to the next phase of product development. And this is why we need to really be careful with planning what is MVP, minimum viable product solution, and really try to be sharp on what is definitely required at MVP and what can be postponed for the time when we have the first market response. So we kind of make this market responses and product improvements loops faster and more of those loops. Of course, we have to remember the pitfalls, like, you know, backward compatibility, data integrity, downtime, and stuff like that. But that's more, I would say, instrumental control we have to have in the projects. For addressing typical pitfalls and risks, the good thing is to stick to this asynchronous hardware and software development process. That's a good way to address the pitfalls. Apparently, it requires more resources or longer project time, but that's, I think, well, the payback, the way to address this. You have to really go in somewhere, and that's what it takes. Alternatively, you can also you know, outsource part of the middleware that belongs to hardware and concentrate on the business features if you want to keep, you know, the business knowledge in house. So that would be also the way to have this asynchronous process to be better deployed at your company and the organization. And then I think what I can say is that a majority of the pitfalls I was telling about today, they are creating a major ripple in the development. So we are not talking about some small hiccups here and there, but some of the things like security, like, you know, battery lifetime, like, you know, having data non-integrity at the cloud. This is critical project and product ripple. And this might potentially end up really destroying the product and destroying also the financial model and return of investment that was planned for your product. So then I was just presenting some of the response to the pitfalls, and majority of these responses are related to proper architecturing, proper proof of concepting, for different, I would say, technologies and solutions for your products. And that's what you really have to plan properly. This is where, you know, the basically the gold mine for the good development is hanging. So that's my recommendation. And as a part of this wrap up, I want to remind all the participants, and we have quite a big crowd today. Thank you everyone for attending. We have 2 more webinars on IoT topic. And the first webinar, or the second, webinar would be on 20th of October about battery power issues and how to tackle the main problems in succeeding with this power budgeting and management. And on 24th of November, we will have the last webinar from the series, where we will look into the practical case, how to actually get into the NB-IoT connectivity and having your product data moved to Microsoft Azure or Telit App Zone, and what kind of, you know, experiences we have gained during integrating those technologies into few commercial products so far. All right. And the last word I want to tell before we go to the Q&A session is that EKTOS is being, you know, a development consultancy. We really want to partner with people who are passionate about IoT and electronics development in general. And, you know, we want to be able to provide the great skill set and great experience we have gained over the commercializing different products and ideas into your products, and help you to actually streamline the development, to have less ripple, less problems, and shorter time to market for your products. So that's all what I wanted to tell you today, and thank you for listening. That was really good crowd to present this information for.
Okay, thank you very much, Alexander. So now would be a good time to post any questions or comments in the chat. Also, feel free to take the floor by unmuting and asking a question directly to Alexander. When doing so, please state your full name and your company or affiliation. Nobody yet. Well, I have a question, or rather a concern, Alexander, for you. How do you foresee the complexity in IoT development is progressing over the next few years? You mentioned that maybe 5-10 years ago, dealing with data was quite simple, but now gets really complex. Are we going to see that growth, and why?
Well, two things to say. First of all, the data models are growing all the time, and fortunately or unfortunately, we need to decide what we want. But having technologies like 5G, where you can basically push whatever you want to the cloud really fast, that's what really calls for the data to grow. That's one thing. Another thing, what I want to mention is that what I see is that software cyclomatic complexity in general in electronics and IoT products in particular is getting more and more complex. So if 10 or 15 years ago, hardware was the main challenge for a lot of products, then today, especially in IoT field, we can see that software is really getting to the king seat in complexity and into growth in development efforts required, and that's what happens. Even knowing that a lot of technologies seems to be really off the shelf, in reality, when you try to implement the technology into the customer product, it's actually more cumbersome, because quite often you have a lot of controversial requirements, like a lot of data being pushed to the cloud and longest possible battery lifetime. Then this is really what complicates stuff as well. So, but generally, complexity is growing, data is growing, and I think the only response to it is to be able to have more solid development processes in house to be able to respond to this complexity.
Mm-hmm. No questions yet. Maybe one final question from my side, Alexander. Where do you place compliance requirements on the list of difficulties in dealing with IoT development?
Yeah, very good question. Well, compliance, it's kind of separate topic by itself, but definitely compliance requirements across different countries and geographies are getting more and more tight, especially on IoT products, because they are radio enabled in majority of cases. And I think we, as the population of Earth, we have been making too many radio products so far. So actually the requirements for taking the frequency band for using your window of operation within the open frequency bands, like with LoRaWAN, for instance, they are getting more and more tight. And this means that the testing of IoT devices is getting also more and more complex. So the good advice here would be to first of all start considering geographies and requirements related to those geographies, or approvals related to those geographies very early in the project, and also to be a little, I would say, realistic about what are the geographies to be addressed. Because what I see quite often is that, especially for the startup projects, is that product owners, they want to push their products across the globe, but the approvals project to be able to sell the IoT product across the globe is actually probably comparable to the rest of the development, because it's really complex and time consuming. So just to put it short, I see this topic as also growing complexity and kind of extra dimension in the development process. And this is also where my team and my colleagues from our test department can help to actually onboard some great knowledge in the very beginning, even when we have the inception phase or product design phase, to be able to kind of put down the requirements and start with in EU zone directives North America, with different legislation matters, to kind of understand the complexity and metrics of the approvals of the product.
Okay, very good. So we have a question from Sebastian. He asks if you will be willing to share this presentation. What is your intention?
Yeah, the intention was that the presentation material is going to be accessible for all the participants. So that would be actually enabled in some way. We have to agree how we're going to share the data, but apparently that would be available for all the participants today.
Okay, so we'll be sending that out within 1 or 2 days. Good. Any other questions, comments?
I have a small question.
Please go ahead.
Yeah, thank you for the presentation. I have a small question. In case if you are proposing the alternative project model for the IoT project, and what is the extra resource that are needed to make that is in good quality, let's say like this, from your point of view?
Okay, good question. Well, it's really dependent on what kind of, I would say, complexity between business functions and system functions you're having in the project. So, but if you take the regular, let's say, Wi-Fi or Bluetooth or maybe Wi-Fi and LoRaWAN enabled product, I would say you would need roughly 50% or maybe even 75% more of software development resources to be put on top of the regular, I would say, waterfall plant process to be able to address the risks I was highlighting today.
Okay, thank you.
You're welcome.
So if there are not any further questions or comments, I think we'll wrap up this webinar. Thank you very much, Alexander, for making this presentation.
I have a question.
Please state your name and your affiliation.
Sergey Gordienko, EKTOS.
Go ahead.
Question regarding it was not a lot mentioned in the presentation regarding the back end of the IoT. Sorry if I missed it because I was late 5 or 7 minutes if it was taken during the presentation. But can you just roughly compare because when you run your IoT project, the customers most likely are interested in the launching the hardware, so to say, that can be sold out. But how to select the backend technology, the ready or develop own, or what are the options, and what how would you compare the size of the project for running a cloud and the piece of hardware that you pretend to sell as a customer?
Well, first of all, for the newly introduced products, I would suggest to always start with ready-to-use backend. Use data brokerage as MQTT or CoAP hosted by by dedicated servers, and then concentrate more on the business logic and app rather than your own cloud. Because you never know how the use cases of the products will evolve when you start the project. Well, you have good idea how they will evolve, but the experience brings something else always, and that would be, I would say, a little naive to think that at MVP launch you can make the cloud solution that would be greater than Amazon or IBM or someone else does. That's kind of, I think that's one of the fallacies I can also tell I see from the client sometimes. And then you can move on when project matures. You can move on to your own backend when you want to save money on running or saving the footprint running the cloud solution. If you compare the development efforts on cloud, I would say, and embedded software, it's really hard to tell depending on what kind of business functions you have. But in general, I must say, as long as cloud and front end are connected to the user experience projects are by nature having spiral life cycle. So meaning you're starting with the outer circle of the spiral, and to be able to get to the dot where the end user is placed, you need to do a lot of circulations. So in my mind, I will be saying that UI UX really brings big complexity and probably also boosts to a double efforts related to that part of the project rather than to the embedded firmware by itself. So that like 1 to 2 for medium complexity, let's say sensor applications. That would be my rough guess.
Thanks. That provides an overview.
You're welcome.
Okay. Any other questions or comments? We still have a few minutes left. It does not seem to be the case. Well, then, on behalf of EKTOS in general, and together with Alexander, I wish to thank you all for taking the time to attend. Please pay attention to the next 2 webinars in the same series as announced by Alexander, and we'll make sure to alert you directly to your emails when we are preparing for the next webinars. So thank you all, stay safe, and hope to see you next time.
Thank you very much. Bye-bye.
Bye.
Thank you. Bye.